definitely say good morning and good afternoon, ladies and gentlemen, because I can see there are people from Australia all the way down to here in Spain. I can see some people from Kuwait. You know, it's really good to see actually German people. You've got some people in Cranfield. It's awesome to see how many people from so many different locations that have joined today. And we're here for this online session on concentrated solar heat for the mining processes. And we have with us two experts in the topic, and I'd like for them to introduce themselves and a little bit about themselves and also where they're joining from. Gus, please, can you introduce yourself and where you're joining from?
Yes, good morning to everybody, or good evening from South Australia. I'm from Adelaide, from the University of Adelaide, and we have a large team here that works in energy, particularly in concentrating solar thermal. We work in a range of areas, but particularly are targeting on applications in the high temperature process industries and through mining as the pathway to that, but also in applications in solar fuels. Thank you.
Excellent, thank you very much. You'll hear from Gus.
I should say, my name is Graham, but please call me Gus.
We will do, Gus. So Gus is going to be talking to us about some work they've been doing there with mining, which is really interesting. And Antonio, please introduce yourself and tell us where you're joining from.
Thank you, Belen. Good morning, everybody. I'm here in Abu Dhabi. Sorry, I'm surrounded a bit of a noise. I'll try to expedite the message. I'm based in Abu Dhabi, representing Abengoa as a regional director, and in both activities in power and water is where we are focused on right now in the area. And yeah, happy to interact with you and explain and present our capabilities and our experience in the mining sector of this technology.
Thank you very much. And I can say now, looking at your comments, guys, that there are people literally all the way from Australia to Chile present in this webinar right now. I have people from Germany, you know, in Italy. It's really amazing, really, I have to say. So thank you very much for all the companies and institutions that have joined. Without further ado, I'm going to ask Gus to share his screen so that he can get ready for his presentation. And this is how it's going to go today. We're going to try and make it really simple. First, Gus gives his presentation, then Antonio gives his presentation. Then we take questions and answers, which you can say through the Q&A box at the bottom. Okay, and just so that you know, we are recording this session, and both the recordings and the presentations will be sent to you after the webinar, so don't worry, you will definitely have the materials. And now that I can see that you're ready, Gus, or maybe you need some more time?
No.
Okay, so if you can just put that in large, because we can still see the small screens, then and keep, by all means, guys, keep sharing. You know, I see people from DLR, from PSA, from Cobra, from Solar Light. Anyway, it's really amazing. Thank you very much for sharing. And okay, go right ahead, Gus.
Thank you, Belen, and good morning again to everybody. So I'm going to talk about the potential for concentrating solar thermal energy in the mining and minerals processing sector. Obviously, commercially to date, it has predominantly been applied in the power sector, although there are, of course, increasing numbers of industry who are seeing the opportunity and making moves into that. And it's great to have Antonio here talking about Abengoa's path there. So some of my co-authors are listed here, but there's a number of us, so feel free to contact any of us. My contact details are there. But perhaps first, one of the global drivers, which comes from the recent IEA report, which plots the global emissions of CO2 in the main sectors projected forwards for about 50 years. And we all know that power generation, electricity, is currently the dominant contributor to CO2 emissions, but we also have the transportation sector and the industrial sector. Interestingly, the other two are expected to decarbonise first, so the projecting forwards, we see that the industrial sector is expected to become the dominant source of global CO2 emissions. So this is really a challenge of the future. And out of that industrial sector, then in Australia, the end use is even greater from industrial emissions. It's about 43%. This is energy use. So this is, of course, there's a big incidence of solar thermal there as well. But if we break the 32% of global emissions down, about a quarter of it is electricity, but 3/4 of it are heat. And out of that, about half is low temperature heat, which in this report, they classified that as 400 degrees, low to medium, and about half is the high temperature processes. And of course, there are commercial systems already available to temperatures of up to 400. And this is why companies such as Abengoa are interested in that. Some of them are steam, some of them are, of course, a lot of them also in air as a heat transfer medium. In the high temperature, this is where it's, well, 400 is commercial, 600, 480 is thereabouts is commercial. But above that, most of the applications are in things like alumina, cement, steel, where the temperatures are typically 800 and above. This is currently pre-commercial, but there are many technologies under development to address that. And I notice some people from DLR on the line who are also involved in that, as we and others are. So I guess Australia, particularly for those in the Northern Hemisphere, may or may not be aware, but this is particularly, I think, an important opportunity commercially, because not only is there is a good coincidence of the high solar resource, but also of where there are many mines. And this is a publication from the Australian government laboratory, CSIRO, showing the coincidence of many mines, but also there are a large number of the high temperature processing, particularly around this region, around Perth and around Queensland. There are a number where the high temperature industries are also being applied. So this is perhaps a market that is of interest. So in the mining sector itself, there are particular opportunities are in the concentration of the ores, particularly copper and iron, etc. Iron is the biggest single fact, but there's a lot of copper as well, copper concentration. So there the temperatures are typically in the steam temperatures of around 180 up to 300 degrees or thereabouts. And obviously this is compatible with commercial systems. Perhaps one of the differences is that many of these systems typically need energy in the order of 10 to tens of megawatt scale. And of course, the energy is needed continuously. It's not good enough just to plug in when the solar resource is available and get stored energy through the summer. It needs to be available all the time. So this means integrating with some kind of backup system. But nevertheless, the opportunities are big because many of these locations are sufficiently far inland or away from the coast that they're typically the fuel may be something like liquid petroleum gas, which is trucked in to the site. So the costs are even more expensive than natural gas, which makes the competitive technologies be even more attractive relative to those. Nevertheless, as I say, absolute reliability is paramount, and maybe some of the technologies such as molten salt, there may be more challenges with maintaining absolute reliability. In the case of freezing, etc., it may cost more to maintain a smaller system. So there are other technologies that are also maybe needed for a very remote site. So there also potentially in the future, many of these sites need electricity for crushing as well as the process heat. So potential for combined heat and power. However, of course, most of the commercial systems are not really targeting that scale. They're typically targeting the larger scale systems. So there are still opportunities for emerging players to move into that scale, and also steam turbines in the order of 10 megawatts or so typically are less economic at that scale. But of course, there are many emerging systems such as supercritical CO2, which may become applicable into that scale in the future. Now, I'm not going to go into the details, but of course, in the minerals processing, there are many opportunities for energy, both electricity, through or potentially in fuels, or direct use of solar, concentrating solar, for example, in directly providing heat into such a process. This is a tower from a preheater tower from a cement plant, but similar towers with cyclones, etc., are used in alumina, although slightly different shape. And we have a big project with the alumina sector that I'll say a little bit about. But first of all, one of the drivers for using the heat directly in a process rather than putting it through a power cycle is that we have the potential to avoid the power cycle losses of a power cycle, a steam turbine, or whichever power cycle that is being used. Obviously, there are a number of commercial systems available using towers to collect heat, which is then put through a thermal storage unit. And this is, I guess, the low-cost storage we all know is the key driver for, or one of the key drivers for concentrating solar thermal commercial systems today. This heat, if it's put through a power block, we have to go through the inefficiency of the cycle, about 35%. But if we can use the heat directly into an industrial process, we avoid that. So this means where we can use the heat twice as efficiently and maybe up to 3 times the economics, except of course that to use commercial systems, we're limited to about the molten salt temperature. So to go to the temperatures such as a calciner, there is also new technologies that need to be developed, and there are many of these under development, although they're not quite commercial yet. So in terms of the cost curve, this is some recent projections of the cost of hydrogen in Australia from our government lab, where typically the cost of hydrogen predicted out to 25 is still about double that of the cost of natural gas in Australia. But nevertheless, the cost of heat estimated from what is typically what we would expect from the solar thermal plants is roughly competitive with the natural gas price. So this is one of the drivers why we see why heat could potentially become economic in these kind of applications. So one of the programs, we have a big partnership with some of the players shown here. Alcoa is the industry partner who the end user. Hatch is one of the technology providers. And then we also have ITP is a solar thermal company. We have CSIRO, the government lab, and also the University of New South Wales as a partner. Adelaide is leading this particular program. Then we're looking at the opportunities with the target of seeking a viable pathway towards 50% concentrating solar in the commercial Bayer alumina process. This is a $50 million, including in kind, program in Australia, which is funded by ARENA, and this is the government agency. And the target is to displace natural gas, which, as I mentioned, the Australian dollar price is $10 a gigajoule. We're looking at 3 different components of this system, which would, starting with what is commercially available today, through to technologies that are emerging and on the horizon. So the transition would take some time, but could begin soon. And so the lower temperature process, we're looking at the combination of what could be tower or trough technology. Probably tower is looking like the one to give the greatest solar share because of the storage. But then this is the steam is needed at about 180 degrees C to do the digestion stage of the process. This is bauxite through digestion, and then a calcination, which is currently runs at about 1,000 degrees, but probably could run lower. And so for that, we're also looking at taking the technology that CSIRO have developed to do solar reforming, to convert natural gas to syngas by reacting it with steam, to put about another, to collect each of these would be around about a, say, order of 17% solar share averaged over the year. And then the high temperature process is one that is not yet commercial. This is the one that we're driving in particular at the University of Adelaide. And then the pathway would then be progressively in hopefully where we are today, completing the evaluations, and then within a timeline of about 2 years, potentially the solar thermal commercial technology could be installed to displace some of the steam, which is currently run on boilers and some gas turbines. Then as the other technologies scale up through to commercialization, then there would be a fuels and or heat process putting in. Then of course, if the natural gas pipeline was also to have some hydrogen, for example, put into it, this would then put a pathway in the future to decarbonize the process. We're not working on that part with this program, we're working on these 3. So there's a lot of work being done on this process. In particular, Keith Lovegrove, some of you may know from IT Power, has been leading this part of the work. but also with CSIRO, and looking at the actual integration parts, working with some commercial suppliers to get some data and costs, and finding out what kind of solar share, what economics would go with that. We estimate the details will be published. We estimate that there will be some subsidy required in the first installation, probably because the location of this site is a brownfield site, not a greenfield site, and the solar resource is good but not outstanding. But nevertheless, after several installations, it would then become economic without a subsidy. And then the other two processes, we're looking at integration. You can see this is one of the Alcoa sites. There is plenty of land around, and we're looking at how this could be integrated by putting in either a calcination process, which hypothetically you could take the alumina out and do some calcination remote and then bring it back in, or you could bring in a heat transfer medium, and we're looking at hot air as being the medium. And again, there are some commercial systems available, but not yet quite the temperatures that we're looking at. So we're looking at the technologies that are available, and also storage systems. We're doing the integration, and I won't go into the details of the process analysis. We're modeling the process and then looking mainly at the energy flows within it, how that would be integrated, and combining that comparing that with the current data, and then looking at the costs of it. To give you an example, where the systems we're looking at, depending on the solar multiple, which is the size of the receiver at the peak solar noon in the middle of summer, compared to the heliostat field relative to that. So typically with a solar multiple of about 2.5, then you'd be talking about a 30% reduction in CO2 at the site at Pinjarra, which is where this site is. Of course, if you're in a location with a better solar resource, such as Learmonth, where there is a bauxite but not yet any mine, then the solar share could be even greater. So what do we see as a highlight summary of where we see the opportunities and the drivers for this? Is now the Bayer process, of which the low temperature process is commercial, similar to what could be applicable at a mining site, although somewhat bigger. But we think that over this whole process, displacing somewhere between 20 and 50% of the fuel with solar heat seems to be realistic. And we think our estimates of the economics are not yet completed, but we think it would be economic with, not perhaps on the first of a kind, probably not, there would need some support, but after 2 or 3 installations, then they could become economic compared with the $10 a gigajoule if the solar resource is reasonable. And we're looking at technology options that require no significant change to the processes. The pathway from commercial steam is obviously commercially available today, and that would be something like the 17% share. Then the pre-commercial technologies are the reforming of natural gas and the high temperature process heat, each of which would achieve a similar solar share, so that collectively this kind of target would be realistic. But of course, the exact solar share will depend on the resource, and also it's somewhat an economic decision as to what level of storage is desirable. In the high temperature process, we're targeting air as the heat transfer fluid, because this is a commercial system that can be directly integrated into the current process without any significant changes to it. And as I say, the preliminary estimates are that the $10 a gigajoule is achievable, although it will require some development to get that. And then the particular technology we're looking at, I haven't talked about that in detail, but we're looking about a directly irradiated solar receiver using a particle-based system. And this is the one we're targeting. And if there are questions, I can talk about that later on. And there are other technologies, including DLR have another technology they're working at. And also there's one being developed through the G3P3 program in the USA at a global partnership, which also has got potential with these kind of temperatures. So there are a number of technologies under development for which these kind of temperatures are achievable. And so that's kind of the direction, and we'll look forward to taking questions later on. Thank you.
Thank you very much, Gus. It was really, really interesting, your presentation. If you can just stop sharing so that we can allow Antonio to share his his screen. So Antonio, please feel free to start sharing. And whilst Antonio shares his screen, I'd just like to take the opportunity to comment on a couple of things that one of our, the people in the audience, but it's actually been really instrumental in putting this webinar together, Arnold, who actually introduced me originally to gas. He sent two really interesting stats. One says that Australian mining requires 5 times more energy than Chilean mining. In the consumption of Australian mining, considering fuels, electricity, and heat, equals the total electricity consumption for Spain. So for those that's quite a lot of energy, I have to say. I know that you've sent some questions. I can see a couple of questions in the Q&A box, and there is one in the chat as well. We will get to them as soon as Antonio's presentation is over, and then we'll take the questions. Okay, so Antonio, whenever you are ready, go for it. We can see your screen perfectly, and now we can hear you as well. Perfect.
Thank you, Belen. Thank you, Gus. Very interesting presentation. As I was mentioning in the beginning, my name is Antonio Moreno. I'm a regional director in Abengoa in the Middle East, based in Abu Dhabi, and we are covering both the power and energy and water sectors from the regional office. Abengoa, my presentation, I will base it a little bit on explaining who Abengoa is, and then I will use an actual project that we have constructed in Chile, where we have managed to apply CSH, which, as Belen says, is not an easy 3 letters to mention. And we always tend to go to CSP. As you know, Abengoa is one of the world leaders in solar applications, and this in particular application of parabolic trough or CSH is one that we are really fostering or pushing, because we do see an important market in the upcoming future. Brief introduction of Abengoa. Who are we? As I mentioned, we are focusing on energy generation and water generation. You see four activities on your screen. Energy generation, where we include all renewable. We're also involved in conventional generation. We're currently building a $1 billion power plant in northern Saudi Arabia, in Turayf. Biofuels is an activity that we're also involved in and pushing, and involved on the early stages where R&D is required. Transmission and distribution is one of our elements where Abengoa was created, and it was the activity that sort of pushed the company where it is today. And in water and environment, we are very much involved, especially here in the Middle East, building 2 plants right now, going into the 3rd one in Saudi Arabia, desalination plants. As you will know, the market in desalination in the Middle East is quite strong, and we are involved in a number of projects. Also, looking at the possibility of adding renewable into the desalination process, and this is something we will present next time with Belen, hopefully. And what are the capabilities and how we see this technology applied into the desal process. And finally, infrastructure and services, which was an activity that takes from transport, railroad, manufacturing, and so forth. Abengoa is world listed in the market, in the Spain market. It's a listed company. Its world references has over 10 gigas in installed capacity and 1.8 gigas in conventional generation. Big numbers in desalination. We have over 1.5 million cubic meters a day in references, and like I said, we are in the process of building 3 plants here in the Middle East that will increase that number. In terms of solar, we do have 2.5 gigas of references around the world, and with the possibility of adding into the renewable mix the wind generation, which in certain applications does come very handy in order to convey to our clients a package solution that involves a number of technologies, in both in photovoltaic when it comes to solar as well as CSP. So let's go into the topic of CSH and mining, and how we got involved, and what were the steps that we were taking, what technologies and what characteristics we ended up applying into the project. No? As you might imagine, mining is a process that requires a whole lot of energy from the different steps of grinding, from transport, melting, separation of solvents, etc. And so there is a huge demand for heat and electric energy that is part of the mix and is part of the product of the mining process. No? Renewable, both for the energy generation and steam generation, is something that has been used, and we have been involved in Atacama in Chile on a mining process generating electricity. But in particular for solar thermal, it's a source of sustainable energy supplying for mining. Why? Because it's a steam heat supplies for unit processes. It's a production we can also combine with a production of electrical power, and it supplies storage, and so we have 24 hours availability. As Gaz mentioned, we have a range here on the top right of the screen of different technologies based on the concentrating factor and the design temperature. We were looking at that range of design temperature that we don't have to go as a CSP application into a 500 degrees Celsius with a large parabolic trough. We are in the 250, 300 Celsius in this particular application, but we can range. The technology, the renewable technology, allows us to implement different technologies according to the best applications, which is this flexibility. We think is one that is going to take CSP in particular to the next level. Abengoa is currently involved in the 600 mega construction in Dubai for the Al Maktoum renewable DIWA 4 project, and this is an application that has taken CSP, reactivated CSP. We have worked tirelessly from the entire value chain to bring it to the competitive level that it was given at the submission at the end of last year. And as I said, we are in the process of executing that project. In terms of thermal energy production, where are we? What kind of references have we developed in the past? In Atacama, like I mentioned, in Chile since 2012. And the top left is one of the largest industrial applications that we have in references in the world. It reduces diesel fuel consumption, which is something that Gaz mentioned, by 55%, and eliminates a whole lot of tons of CO2 annually, which is also something that we're very interested in promoting as a key aspect of our technology. No? You see on the top right a correction institution in Colorado, where also is being for a number of years in operation with hot water storage. On the bottom left, we do have a large thermal system in the US, also used to an industrial process, and you see another reference there in the bottom right. So regarding mining, I put together a bit of a summary of the main points. This project was in response that we were approached by a mining company into Antofagasta in Chile, where they was currently using diesel oil to heat from about 55 to 80 degrees Celsius. And they wanted to see what kind of application, what solar field application was feasible in order to replace at least 60% of the fuel use. No? It's a large industrial solar application. Okay, it was delivered for in the Atacama Desert. What we did in the design, we put together a bit of a analysis process where we analyze a parabolic trough energy collector with direct thermal energy storage with TAS. We use water for the heat transfer fluid in the solar field and in the storage for the TS tanks. The main goal was obviously to predict the performance that we wanted to implement, and in order to transmit that the best optimal solution to the client. And we wanted to, as a benchmark, obviously compare to the required oil and how much oil we could displace in order to optimize the amount of TES. We use meteorological data that at the time in 2009 it was provided by the client. It obviously had certain number of assumptions that we had to make in order to make the best of the application. With regard to the load, an average monthly diesel use and water outlet temperature were used to define what kind of hourly flow rate and water inlet temperature was required. And obviously we had to consider variations when winter and summer times, and the modifications and different requirements that we had in diesel and oil consumption. No? We run different performance models to evaluate the annual performance, and we use different tank volumes with different parameters of 200, 300, up to 500 cubic meters. And we use different types of modeling in order to come up with the most optimized design. No? What was the result? The result, as you see there, we had a solar array providing thermal energy for 24 times 7 electro mining process units. It was, at the end of the day, it was a parabolic trough field with 21,000 square meters approximately, and a storage volume of 400 cubic meters of water. The solar field that completed were available in 2 pieces of separate land, and we reached the target estimated by or asked by the client of reaching a savings of 60% of the fuel savings. You know? You see there on the screen the number we managed to save in terms of the diesel used in 2 heaters was up to 55%. It was needed to raise the temperature of the solutions. So it's a project that it's saving 10,000 tons of CO2 annually. And it's a project that is really an example of what this technology is bringing us to in the coming future. We see a possibility in both the mining sector and pharmaceutical and the industrial processes where steam is required. In order to analyze and to come up with the most reliable solution, we saw that it was quite critical for us to understand really the process and the requirements and what was the critical aspect for the client to go into a renewable solution. No? At the end of the day, CSH is a technology, and in this particular application, we went with a maximum solar field out loud temperature of 185 degrees, close to 200 degrees, which is a reasonable temperature for and quite common for an industrial application. We were able to reach 14 bars of tank pressure. That is also an application. It was also a requirement given to us by our client. Like I said, we use heat transfer fluid as water, which was also a way to optimize and to make the application the most efficient possible. And at the end of the day, we do have an interest. Like I said, in the audience, there is a possibility of redirecting this project into an application. We have several possibilities already detected here in the Middle East. Why do we think CSH is key for for the future, and what are the advantages? No, what are the positive sides of it? It's obviously a reliable supply. It's by using fully integrated storage. CSH is a solution that can work as required by almost any industrial application, which is 24 hours non-stop. It does solve the issues, as we did in Chile, of transporting diesel to remote areas, which is the location where mining locations are, or mining plants are located. It reduces the risk and the cost of allocating for the operating budget of the plant, also the use of diesel. And finally, worth mentioning the savings and the good reduction in carbon emissions, which is an aspect that Abengoa has always been very critical on. No? So that is a bit what we've done in this project, and we're open for any questions that you might have.
Thank you very much, Antonio. As it turns out, there are a lot of questions. I would ask you just to stop sharing so that we can see you a little bit better. And okay, so first, I'd like to ask Graham, you've been answering a number of questions. Can you give us a little bit of an understanding of what were the questions generally, you know, that you've answered, not one by one, but just an idea so that, you know, we go from there?
Yes, there's been some really good questions. Some people have commented on the emergence of some of the more modular solar thermal technologies, and I agree that these are one of the important opportunities for use in the mining sector. And there isn't very much data really that I'm aware of really how these systems are performing, and we'd be really keen to be part of working with others to better understand how these different technologies compare, where their sweet spot is in terms of different scale. This is really, I think, getting a better understanding of where they fit will open the door to the sector being able to better expand these. But I do agree that some of the modular systems are one of the opportunities. That was definitely a good question. But maybe some of the other ones may also come up as well.
Thank you very much. Okay, so let's see. There is a few here that still haven't been answered. Even I actually answered one because I've learned it from your presentations and from other presentations I've heard. It was about the range of temperatures, you know, that you can see in these processes through CSH, which goes from about 100 to 400. And actually, this has also been answered by someone else, Pablo Prado from Rio Glass as well. And, you know, so below 200 to 400 is what he's answering here. So, Antonio, there's a question here that is directly for you. For Mineral Tesoro, what made small-scale CSP more attractive than flat plate collectors, which has also been deployed in the Chilean mining industry?
Yeah, it's true. In our project, also because it's parabolic trough is the technology that quite frankly we had been testing in our research center, and we did have an understanding of its performance and of its capabilities. That's why in this particular plan we went in that direction. It is true that flat panels is also a possibility. In our case and in our experience, we've seen both in thermal and obviously in energy production to be more efficient to use parabolic trough. Industry has been evolved as the speed as it has, particularly with this last year. We see a possibility in the supply chain to be diversified and maybe go into a bit of a exploration into some other panel shapes, no? But as of right now, this is the application. This was a few years back, and we see that in order to reach a temperature required of 190 degrees roughly, it was a good application, and it was price competitive as one of the questions that was also asked.
Yeah, I mean, at the time as well, the energy in Chile was extremely expensive. Anyway, there is a lot of context here that I suppose it helps, but this has been at least 5-6 years already running, and at the time, as I say, the energy in Chile was off the charts. So there's 2 questions here from Christian about the topic of storage, 24-hour necessity. Can you use molten salt? Is there only ways to do it? Is it economical? So this is going back to what we call the levelized cost of storage, which is really something that I hadn't heard a lot of for anything that wasn't electricity related until we organized a conference on behalf of the World Bank in Amman recently, and this came up a few times. So I'd like to ask you, I don't know who wants to start to talk about this topic. Do you see it economical? Do you see it plausible? Is it already hard? You can start, Gus, and then we'll take it to Antonio.
So this is a very good point. We see a lot of opportunities in emerging types of hybrid technology. We see that storage is typically economic up to around about 12 hours or thereabouts, depending on the system. Obviously, some storage is really essential if you're going to be having a high solar share, a high displacement of fuels. So we really think that is critical. However, beyond the more you go above about 12 hours or thereabouts, the more you end up having lower utilization factor of the storage system, and not only the storage system, but also the heliostat field. You need then a bigger solar factor. So then the economics start to become more challenging as you go far beyond that. Of course, exactly the sweet spot will depend. However, a hybrid then, a commercial hybrid simply involves a backup combustion system in the system. But there are now emerging technologies where the hybrid is integrated into the solar thermal plant. So then you can maybe make better use of the storage system by, for example, mitigating in how much of the thermocline is being lost, or maybe bring it into a receiver so that you can also help to reduce thermal shock of the receiver tubes, or whichever kind of technology you have. So we see a whole lot of opportunities in the next generation of hybrids, which are not yet commercial. And of course, moving forward into the future, we see the fuels will gradually be displaced with what is currently fossil fuels to alternative types of fuel. So the heat will be the cheapest form of low carbon fuel, up to maybe 50, maybe 60, maybe 70% of the energy, depending on the solar resource. But then beyond that, then alternative fuels will then increasingly become, but their cost will also vary. So where that sweet spot is going to go as we move into an increasingly low carbon future will depend on the local context. But we see emerging hybrids and their displacement with fuels eventually is becoming, where that crossover will occur is going to take a lot more work to understand as the technologies emerge, but that's the way we see it going.
Thank you very much, Gus. Antonio, your chance. Yeah, a bit in line with what Gus was saying. No? We see in the recent solar applications, the storage being the competitive advantage of CSP or CSH. We see 6, 8, up to 10 hours of storage starting to be common in our solar activity. Again, I should emphasize the importance of going down the supply chain and diversify the suppliers that we have available for certain components of our technology, and especially molten salts. It is a critical aspect and a very positive advantage that CSH has right now with regards to other solar technologies. And I'm thinking, obviously, we're all thinking of batteries, which is in terms of the capacity of storage behind, and it's going to take some time in order to become commercially viable. So yeah, I mean, we do think it's a critical aspect. It's an application that it does bring reliability to the technology, as we were saying in the presentation, and for us, it definitely goes hand in hand with the technology.
Excellent, thank you very much. I'm hoping to see 24/7 for this kind of, because I think that is the mental break that still, when people think of renewables, have to overcome. I think once that is overcome and everyone starts thinking of renewables as 24/7, then we might see also a resurge, you know, of CSH and CSP projects. Okay, so there's a question here that is quite interesting. It says, what are the advantages, disadvantages you see as solar heat as compared to renewable power to heat? So who wants to take that?
I'm happy to say something. I think the power to heat obviously is growing. A lot of people are interested in seeing electrifying totally energy systems, and I see there is opportunity for that to some extent. However, the key challenge with electricity is still the cost of storage, and the market of electricity goes up and down. And although electricity can be cheap in periods, there are also times when it's expensive. So there's generally the cost of electricity itself from the places we've looked at is not really showing a sign of reducing. So I see electricity to heat will probably be, I mean, an end user who wants heat, they just want the lowest cost source of heat. And they probably, the ideal black box for them would have 2 or 3 or 4 different options they can choose from depending on the price of the markets. If there are periods when electricity is very cheap, then they would probably love to tap into that. And that might be, in my kind of hypothesized mix of the future, I think that may be something like 10% of the energy mix of many plants. But I don't think it's going to be much more than that, because going to heat directly from concentrating solar is likely to be much cheaper, I think, than going to heat via electricity. 2 reasons. Not only do you avoid going through the 30 or the 60 to 70% loss of the power cycle, which gives you a 3 times gain, and then already stored heat is already competitive with stored electricity in most locations. If you put on top of that the cost of avoiding the power cycle, it's pretty hard to see it as being competing with that as the main source, although there will be periods, of course, when renewable electricity will become cheap. The other thing is that in terms of, depending on the sector, of course, there could be sectors, of course, where heat from electricity will make sense, and I'm sure there will be shares of the market where this will occur. But in terms of the high temperature process industries, and again, there are some which already use electricity, such as, you know, the aluminium smelting. And nevertheless, if you're talking about the pathway to introducing new technology, our experience with working with industry is that a technology needs to be able to be demonstrated first in retrofit. This means, this is because there's very large capital cost and no one wants to invest in a new plant with big risk that hasn't yet been proven. So we need to be able to demonstrate something in a technology that's already there. So this means starting with the heat-based processes that are already there, demonstrating a retrofit into part of the process, getting that proven. This is already going to take these plants have got 30 to 50 year life, so it'll take some time to displace them. So therefore, any transformation to electricity is going to need to have a pathway to demonstrate the new technologies, unless they come in a very much smaller scale. But generally, there are so many other economies of scale in this manufacturing, in the heavy industry sector, that it's hard to see them becoming competitive at small scale. So therefore, I think the retrofit pathway is the pathway to demonstrating new technologies, which means going via heat in the dominant sector. So for the high temperature processes, you know, we don't yet have commercially demonstrated systems or on the horizon of bringing in, although there are things that could be conceived of, such as plasma. So I think that electricity will play a growing role, but in the foreseeable 10 to 20 year time horizon, I see solar thermal as being the easier path in. This is my perception from what I've seen and engaging a lot with industry, I've worked in, cement, lime, alumina, steel. I've worked in glass. I've worked in a lot of these heavy industry processes, and this is the path that I see as being most plausible for many of them, although I'm sure electricity will play a role in some sectors, and there will be, I'm sure, surprises as well.
Thank you very much, guys. I'd like to jump to a different question now. This one for you. Actually, there's 2, but I'm going to combine them. So one is like more, Loreto Valenzuela from PSA. We send you greetings from here. You know, we know Loreto quite well. She says, About the case study of Mineral Tesoro, how many years of operation have been accumulated? The heat provided by the solar field was varying from 1 year to the next. It would be interesting if some performance figures of the system were shared. I mean, differences in heat production from season to season and from year to year. Sharing more detailed information about this running CSP project could help attract new users. I'm not sure this data belongs to Abengoa. It may belong to the Minera, right?
Yes, that is one of the issues, but it's true that it's a critical aspect in order to convince new clients and to prove, like Gus was saying, that the technology is viable and it does have a number of years of running. So I agree with her. I will try to dig some information. If I can find it, I will send it to you, Belen.
Okay, yeah, and I can pass it on, or and also your details are, I think, in your presentation. There is also one here that says.
The lawyers will ask us to sign an NDA, something like that.
Yeah, you guys, no problem. I pass them back and forth. You know PSA, you know people at PSA, you know what they do. It would be good, I think, to have more data. But I know in this particular case, because I visited Mineral Tesoro a bunch of years ago, that they said that that's their data. So it says here. What's the total square meters of PT in the Atacama project, and what is the annual megawatt heat generation and annual DNI for the area? They're just trying to calculate, I think.
Asking about Atacama.
Correct. Yeah, the project. I'm assuming they mean the mining project, of course. Yeah, because it says.
Okay, here we have about 22,000 square meters of total solar field area. And what was the other question? The dimensions?
The DNI.
Sorry?
The DNI in the area.
The DNI was varied. I do have some tables here with information. Maybe I can send it over to you and as a reference. Yeah.
Absolutely, we can always, if you've got it, then.
This was 2009 data that we received, and I do have some of the information here.
Right, so another question, this one's for Nathan. How commercial should be the technology to be considered for these applications? Should it be bankable? And what sort of TRL? I don't know what TRL stands for, so does that help you understand the question, Gus?
Yes, I think any time a technology is applied in a different sector, there is still some risk. So, for example, the industry such as Alcoa and the alumina sector would still consider there being some risk in going from a boiler system into a solar thermal process to provide steam into the plant. This is because there's a need to maintain the integration into the process is important. We need to maintain 100% reliability of the steam. It's the integration, it's managing the variability. So the risks are probably fairly low when installing a commercial system from one application to another, but there still are some risks. So the question is very good, because obviously things need to be demonstrated and proven. And I guess this is why, for example, in Australia, there is the government has a renewable energy agency, which will be in principle are prepared to put in some support to making the difference between a commercial decision and a new technology. So I think for any of these technologies, they need to be proven, and there needs to be investment to get them to the point where they've been demonstrated for several years in the same sector. And that is the stage when then the risk will be low enough that they can then be taken on as a commercial product by themselves. So in the early stages, there is more need for demonstrations, and these will need some support and investment to build up that record.
Thank you very much. Okay, we don't have a lot of time because we're running out of it, but there is one thing that I wanted to just clarify here. For some reason, I lost my, oh, here we go. There is someone here that asks, we need electricity, we need heat, how can we combine the both? Combined heat and power is definitely a possibility, right, with the CSP/CSH system. I just wanted to make it clear and ask you guys just to be sure that this is perfectly possible. Right, so Luis, that is your answer. It's perfectly possible to do a combined heat and power.
I mean, obviously the key point is that it's definitely possible, but we have to match the amount of heat and the amount of power that are needed in site to site, and they may not necessarily be well matched, and also the efficiency of the power block may not be so efficient at smaller scale. So there are challenges in making it work, but the opportunities are really very large potentially, because and quite a few seem to be well suited to it. But I think getting demonstration in the mining sector where you have because many, at least in the Australian context, I'm sure Antonio will have different comments from the sites he's looked at, but in the Australian context, quite a few are off grid, so you can't necessarily sell power into the grid. So you have to match it with backup systems, and there are a number of things to consider, but the opportunities are certainly very big, particularly if we can get efficient enough power blocks.
Excellent. And then I suppose last but not least, because we really have to go, is it says, why don't we see more CSH plants? They sound amazing. You know, what are the main hurdles? And let's just try to get at it really, really quickly so that we can leave it on a high. Antonio, did you want to start?
Yeah, like we said before, this is sort of a technology that's been applied into a sector that maybe was not very conscious of renewables. As we have said, the solution to renewables is usually a combination and a mix. So definitely renewables and mix go together in terms of providing the most optimized solution. And that's what we're trying to foster. So yes, I agree. We need to push this technology forward, and these applications which are reliable and it has been proven to be economically feasible. And we need to find also the right clients willing to move away from the traditional ways.
This is the missing link, the client. All right, so Gus, go ahead. What are your main hurdles that you see there, just very shortly?
Oh, I mean, I endorse that comment from Antonio. Certainly from the mining sectors that we're speaking to, there's a lot of interest in Australia for exploring these possibilities. And I guess the challenge in the pathway is really the key, is to get the demonstrations and really build the experience, because there are some different challenges in the remote sites, but they're all can be overcome. Just needs the demonstration and the experience to build it up.
Well, thank you very much. Thank you very much, guys. Thank you very much, Antonio. It's been a pleasure to have you here. And it's been a pleasure to have also this amazing audience from everywhere in the world. Obviously, this is a topic that matters to you, and it matters to you enough that in your evening or very early in the morning, you're there. So we really appreciate you coming to this and being there and being interested. We will keep on doing some more of this. You know, Antonio just mentioned the one on desalination that we have in the next few weeks. And of course, thank you also to Arnold for introducing me to Gus in the first place. And I am really looking forward to seeing you in the next webinars. As you know, the ReLearn program, we look at everything that is interested to renewable energy types. So sign up for our webinars. There is definitely something for you in there. Thank you very much, and I see you next time. Thank you. Bye.
Thank you very much.
Thank you all.
Bye.
Bye.